All right, class, now we're going to start chapter 5, which is all about normal distributions. So section 5.1 is kind of an introduction to a normal distribution, and that starts with the question, what is normal? Here are our learning objectives. So over here on the right is a histogram for the distribution of 300 natural births. The left vertical axis shows the number of each birth, so the frequency. And we can kind of see that it fits this beautifully curved, normal curve, bell curve distribution. So a normal distribution is symmetric, meaning it's like symmetric like a butterfly, bell-shaped, and it has a single peak. That means it has a single mode. This peak is our mean, median, and mode of our distribution. And we characterize its variation by the standard deviation. That's something we learned to calculate at the very end of chapter 4. In this class, we're going to use the thumb rule, the rule of thumb rule, which is range divided by 4. Now let's take a look at both of these graphs. Are they both normal? Well, in order to be normal, it needs to have one peak and be symmetric and be bell-shaped, and both of those do that. The reason for their difference in shape is that one has a larger standard deviation, meaning its data values are more spread out, and the other has a smaller standard deviation, meaning its data values are more concentrated towards the mean. So let's talk about the normal distribution and relative frequencies. So the area that lies under the normal distribution curve corresponds to a range of values on the horizontal axis, and it is the relative frequency of those values. Because the total relative frequency, remember we made it relative, so we divided it by the total number of pieces of data, is 100%. The area under our curve is 1. If that's like the one key takeaway you get from this section, the area under a normal curve is 1. So here is our bell curve for due dates. It's figure 5.5 in your text. So the total area under our curve is 1 or 100%. We can use these regions to tell us more. So for an example, this region here has about 18% of the total area under the curve. So its relative frequency is 0.18 for births more than 14 days before the due date, because 0 is our due date. These are all the babies born 2 weeks before their due date, and that's about 0.18 or 18%. For babies born 18 days after their due date, this area is 12%. So the relative frequency is 0.12 for births more than 18 days after the due date. And we're going to learn how they calculated that 0.18 area and 0.12 area in section 5.2. So let's look again at our normal distribution. Why don't we go ahead and estimate the percentage of births occurring between 0 and 60 days after the due date. So keeping in mind that the total area under our normal curve is 1. So I'm trying to find the area over here. Maybe I'll switch to orange. That's a little brighter. I'm trying to find this area. Well, remember it's symmetric. So if I divide my normal curve exactly in half, the area on both sides is 0.50. So that corresponds to 50%. So 50% of births occur between 0 and 60 days after the due date. So let's look again. What if I wanted to estimate the amount of births between 14 days before and 14 days after the due date? Well, I know that 0.18% occur before 14 days, and because it's symmetrical, that must mean that 0.18 occur after the due date. So if I want to know what occurs in the middle here, I'm going to take 1 minus 0.18 minus 0.18, which would give us 0.64. So 64%. I think I did that right. 18 and 18 is 36. 100 or 1 minus 0.36 is 0.64, so 64%. Cool. So what are the conditions we need for something to be a normal distribution? So first, a data set that satisfies the following 4 criteria is likely to have a normal or nearly normal distribution. So first off, our data values are clustered near the mean. 2, they're spread evenly around the mean, making our distribution symmetric. And larger deviations from the mean, meaning data values farther and farther away from the mean, are very rare. And that's what produces the tapering tails. We call those tails of our normal distribution. And fourth, individual data values result from a combination of many different factors, typically natural factors, such as genetic and environmental factors. So which of the following variables would you expect to have a normal or nearly normal distribution? Scores on a very easy test. Well, if the test is very easy, most people are going to score high, so this does not have a normal distribution. What about tree lengths in a forest? Well, that's something that occurs naturally, so we would expect that to have a nearly normal or normal distribution. Next, what about foot lengths of a random sample of adult women? So foot lengths, I do believe, as that is naturally occurring data, this is going to have a normal distribution. Luggage weights on an airplane. Well, I think it depends who you're flying with. I want to fill that bag to the brim, so I'm going to say this is not normal. And most people, I think, overpack. And then the temperature of an oven when it has not been turned on or open for 1 day. Well, that's something that occurs naturally. It's probably really boring and probably, stayed about the same temperature. So I'm going to go with a nearly normal distribution.